3.3 Formula weights. So the formula weight of a substance is the sum of the atomic weights of all the atoms in its chemical formulas. In short, you're just adding the weight of each atom in the molecule. They are in AMU or Daltons, which are just another form of mass. Kind of like grams, but they're a lot smaller here because atoms weigh like nothing by themselves. So don't worry about how they were found, just use them. You can find them on the periodic table. And let's practice on sulfuric acid. So we'll come over here, and we already have it written out. So we come into the periodic table, and we see here that H is 1.0078. So that just means that we use 1.0078. And we'll just write this as 1 actually for simplification because 0.0078 is very small. And hopefully you'll memorize the AMUs, which it'll come to you when you keep practicing chemistry. This one is actually 32.065, which is right here, but I just want to show you guys. So 32.065. And then we have 4 oxygens here, which is 16, which I'm going to use, but it's 15.999, which is actually right here. So I'm just going to use the simplified versions so I can show you my amazing algebra skills. So we have 2 plus 32.065 plus 64, and that's going to be 98.065. So this, in short, is simply how much each molecule weighs. And later you'll learn that AMU is also how many grams are per mole. Sorry, 92.065. So that means in 1 mole there is 98.065 grams of sulfuric acid. So we'll come back to right here. And now we just need to know the formula units for ionic compounds. They're actually just the same way to calculate them, but instead of molecular weight, we refer to the formula unit weight, and the method of calculation is the same. They're not really going to care about that in real life, so who cares? But what it means by the existence lattice structures simply means that let's take an empty canister right here, or not empty because there are going to be some atoms in there. So this is a flask actually, which is the better terminology. And ionic structures or ionic compounds are typically solids because of their high electrostatic attraction, which you'll learn in later episodes. So this is like O2 or oxygen gas, and let's just say they're all floating in a flask. They're all floating and they're all hitting each other, moving each other side to side. However, an ionic compound in the same flask is gonna be a mixture of, here, let's put it down here actually, positive and negative ions. So these drawings are pretty bad, but anyways, all of them are connected together because of the negative and positive charges. As we know, like charges repel, and opposite charges attract. So it's like this. So it's really hard to calculate the AMU of this entire thing because you can't. So instead we just take the simplest whole unit, which would be these two, and calculate the AMU that way. So